So after the idea of quantum came into place, the classical free electron theory was replaced by something called the quantum free electron theory, which made some modifications. So the wave nature of electrons and the quantization of energy levels were taken into consideration. So with quantum we realized that there is something called the wave particle duality, right? So the classical theory, it looked at electrons strictly as particles. So a particle, it moves, it collides, its velocity changes and all that. But now that the idea of quantum has been developed, we know that every particle also has an equivalent wave nature. So that wave nature was taken into consideration, and the idea that energy levels are quantized, they cannot be continuous, was also taken into consideration. So some assumptions from the previous theory were changed here. Firstly, energy levels are discrete, not continuous. That is self-explanatory. Second and third, they obey Pauli's exclusion principle and Fermi direct statistics. So these two are more or less similar, and what they mean is only two electrons can occupy one energy level and each of opposite spin. So you have n equals to 1, you can only have two electrons there, and each should be of opposite spin. Spin is the direction in which they revolve, for example. So based on these assumptions, it was understood that all electrons in a metal do not take part in the conduction process. Only a subset of them closest to the highest field band at 0 Kelvin take part in conduction. This is an important point. So according to classical theory, because of the assumptions there, it was assumed that when you have a setup, you have an atom, you have nucleus, you have electrons, you apply some heat energy to it, it was assumed that all electrons will take up the heat energy and they'll start moving to higher energy levels. Or no, not energy levels, because the concept of levels did not exist back then. All electrons will take up heat energy and get excited, and energy will increase for every electron. But now when quantum came, they realized that that is not the case. Now whichever electron is already in the highest energy level, only that gets excited and moves. For example, let's say this is my setup. So I have 1, 2, 3, 4 energy levels and 7 electrons. Now if I apply heat, all 7 are not going to get excited at once. The classical theory assumed that all 7 will get excited and gain energy at once, but the quantum free electron theory says the electron in the highest level, this one, gets excited first, it moves to the subsequent level. Then if there is still some heat energy left, these two will get excited and they'll move up. If there is still more energy left, then these two will get excited and move up. So only a subset of them close to the highest band will take part in conduction. The free electrons move in a uniform potential, free and independent electron approximations. These two are the same assumptions from classical theory. There is no change. These were still accepted by the quantum theory. And then n replaced by n effective. N represents the number of electrons in the classical theory, the total number of electrons present, because they thought all electrons get excited on the application of heat. Here we replace it by n effective because we know that all electrons do not gain energy, only a small subset of them gains energy. So n effective refers to the number of electrons which gain energy upon application of a certain amount of heat. So let's say I give 300 joules, then let's say 5 electrons are going to get excited out of 12. If I give 500 joules, maybe 7 electrons will get excited. So in my first case, n effective is 5, in the second case n effective is 7, and so on. So it is the number of electrons out of total which get excited when a certain amount of heat is given. So these were the assumptions of the quantum free electron theory. But although this drew from the knowledge of quantum mechanics, it could still not explain some concepts like superconductivity, semiconductors and insulators. So even though this overcame some of the limitations of classical theory, it still had its own limitations.